Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on analytical geometry for mathematics grade 10. And this question comes from the November 2019 Department of Education. And question 2 goes, in the diagram below A13, which is this, and point B, x, y, and point E, -2, -1, are points on the Cartesian plane. Point C, with the coordinates 2, 1 is the midpoint of AB. Also, F is a point such that AF is equals to FB, and this ABF forms a right angled triangle. And AF is perpendicular to FB. 2.1, determine the length of AE. Here is the length of AE. We need to determine the length of AE. Now here is the equation that you use. Whenever you find the length of any segment, that is equals to, let's fix that, that is equals to the square root of, in bracket, x2 minus x1 all squared plus, in bracket, y2 minus y1 all squared. That is the square root of all that. Now, point A has got the coordinates. Let's go. Now, x2 minus x1, AE, let A13 be x2, x1. It's up to you which one you decide to make, x1, x2. It does not matter. So I choose to make this x2, y2. So that will be 1 minus -2. That will be equals to 1 minus -2. All squared plus y2 minus y1 will be 3 minus -1, 3 minus -1, 3 minus -1, and that is all squared. Take out a calculator. That will give you equals square root of, open bracket, so that gives us square root of, open bracket, 1 plus 2 all squared plus, in bracket, 3 plus 1 all squared, which is equals to square root of 3 all squared plus 4 all squared, and that gives us square root of 3 squared plus 4 squared. That is equals to 5. That is the length of AE. Now, for the gradient of AC 2.1.2, gradient of AC, there is AC. The gradient of AC is 2.1.2. 2.1.2, the gradient of AC. The gradient of any point is y2 minus y1 over x2 minus x1, which gives us, for this case, let C be your x2, y2, or A be your x2, y2, that's fine. So that will be 3 minus 1 over 1 minus 2. 3 minus 1 over 1 minus 2. 3 minus 1 over 1 minus 2. And that gives us 2 over -1. That is equals to 2 over -1. And that gives us -2, meaning that the gradient of AC is equals to -2. Next question, 2.1.3 goes, the coordinates of B. The coordinates of B. B is the missing coordinate. You've got a midpoint C and the other point A. So these A and B are the points flanking the midpoint. Now when you find the missing points, the missing coordinates of a point, when you've got the midpoint, you use the midpoint as your anchor point. So that will be 2.1.3. Now the x coordinate of the midpoint is calculated by adding the x coordinates of the other 2 points and dividing that by 2, and that gives us the coordinate of the midpoint, that is the x-coordinate of C. The x-coordinate of C is 2, and the x-coordinate of A is 1, and the x-coordinate of B is x. So that will be 2 equals to 1 plus x. Therefore, 2 equals to 1 plus x all over 2. Now you multiply both sides by 2. 2 times 2 equals 2. What you do on the left-hand side, you must also do on the right-hand side. The 2's cancel out over here. And that leaves you with, on the left-hand side, 4 equals to 1 plus x. Now 1 plus x equals to 4. 4 equals to 1 plus x. You take the 1 to the left-hand side, and that leaves us with 3 equals to x. That is the x-coordinate of the point B. Now the y-coordinate of the midpoint is the sum of the y-coordinates of the 2 points divided by 2. Now the y-coordinate of C is the midpoint. We go back. The y-coordinate of C is 1, and the y-coordinates of A and B are 3 and y. So that will be 1 equals to 3 plus y. 3 plus y over 2. Now you multiply both sides. 1 times 2 equals to 2 times 3 plus y over 2. The 2's cancel out over here. That leaves us with 2 on the left hand side. Equals to 3 plus y. And now we take the 3 to the left hand side. Therefore, 2 minus 3 equals to y, meaning that negative 1 equals to y. Therefore, the coordinates of B are the x-coordinate is 3, so that will be 3, and then y-coordinate is negative 1. These are the coordinates of B. Next question. BE is joined to form a special quadrilateral AFBE. Name the special quadrilateral AFBE. Give full justification for your answer. So we join BE. There is us joining BE. Let's change this. Make it purple. All right. Now, the coordinates of B, we said the coordinates of B are 3, negative 1. So the coordinates of B are 3, negative 1. They are on the same y level with the point E. So the distance between the two is simply the distance between the x-coordinates. So EB will be equals to EO plus OB. Okay, O because that's the x-coordinate. I mean, you can call that there. So that is 2 units plus from the y-axis to point B, that is 3 units, and that gives us a total of 5 units. Now this is the same length as the length of AE that we just calculated. Remember when we calculated the length of AE, so meaning that these two sides are equal, and that therefore makes this a kite. This is 2.2. Kite. And the reason why is because both pairs of adjacent sides are equal. Because both pairs of adjacent sides equal. both pairs of opposite and sort of both pairs of adjacent sides equal. That's what makes a kite a kite. The last question goes 2.3. Calculate the area of triangle AFB. We're going to calculate it exactly right here. Now let's calculate the area of triangle AFB. 2.3. The area of a triangle is equal to half times base times perpendicular height. Now let's go to triangle AFB. Triangle AFB. This happens to be a right angle triangle, making it easy to calculate because we already have AF, or we can choose BF as our perpendicular height. The base is AB, so it will be easy to calculate. Now we need to find the length of AB, and we also need to find the length of AF or BF. Now the coordinates of F will be found in this way. Now we know that. What are the coordinates of F? We know that because this is a right angle triangle, we know that the length of AF squared plus ABF squared equals to AB squared is AB squared equals to AF squared plus BF squared. The reason is Pythagoras. Therefore, x2 minus x1 all squared plus y2 minus y1 squared equals to, same story over the x2 minus x1 all squared plus y2 minus y1 all squared plus, same story for that, x2 minus x1 all squared plus y2 minus y1 all squared. Now let's substitute. Okay, the points for AB are 1 minus 3 or 3 minus 1. It's up to you how you want to do that. So that will be 1 minus 3 all squared plus, and the y will be 3 minus negative 1. 3 minus negative 1 all squared. Minus negative 1 all squared equals to x2 minus x1 for AF. Okay, let the coordinates of F be x, y. So that will be 1 minus x all squared plus 3 minus y all squared